Good afternoon, everyone. I'm Shaina Verma, and I have completed my BTech in Electronics and Communication from Chandigarh University, India. Before starting my presentation, first of all, I would like to thank the organizing committee of this conference for giving me this opportunity to present my work in front of such great researchers. Thank you, sir. The topic of my research work is Input-Output Standards-Based Energy-Efficient Design of Room Temperature Sensor. Now the question arises is why I chose this topic. Like when there is a mishappening, the fire or other thing like the temperature of a room increases. So to detect the mishappening, I have designed this design. In case of fire alarm, what is a room temperature sensor? It is a sensor that detects the temperature of the room. The various input signals that are of the room temperature sensor is the clock input, the temperature of the room, the threshold values, and the additional airflow. And the output is in the form of fire alarm, and if there is no fire, then no alarm will be there. Now what are the techniques that are implemented in my design? This design has been implemented using various input-output standards. We have various I/O standards like the LV-CMOS, SSTL, HSUL, PCI, etc. In my design, I have used HSUL 12, Mobile DDR, PCI 33, SSTL 18. And the other technique that I have implemented in my design is the temperature scaling process, in which the temperature has been scaled down from 50 degrees Celsius to 25 degrees Celsius. Now talking about the input-output standards. Firstly, what is HSUL? HSUL is high-speed, unterminated logic that requires a differential amplifier and a push-pull output amplifier. This standard is basically supported by the ultra-scale devices for single-ended signaling and differential signals. Now talking about the mobile DDR. DDR is double data rate synchronous DRAM that is used for mobile computers. It is also known by MDDR, low power DDR and LPDDR. And the third input-output standard is PCI, that is Peripheral Component Interconnect. It is a standard that describes how the peripheral components of a system can be connected together in a structured manner. And the fourth I/O standard is Sub-Series Terminated Logic, SSTL. There are two types of SSTL that can be operated on 2.5 volt, that is SSTL2, and the second one that operates at 1.8 volt. And in my design, I have implemented it using SSTL18. This standard also requires a differential amplifier as the input buffer and push-pull output buffer. Now there are various parts that are associated with any device. That are the input power, clock power, logic power, leakage power, and the total power. When I simulated my design simulated my design, and then the clock power for at all the temperature values, that is 25 degrees Celsius, 30 degrees Celsius, 40 degree, and so on up to 50 degree. The clock power was same for all the I/O standards, and there was no leakage. There was no logic power and clock power associated with the design. So when the I/O participation, when the migration I/O standard was migrated from SSTL18 to HSUL12, the input-output reduction was 17.29%. And when the iOS standard was migrated from SSTL18 to mobile DDR, the reduction was 65.22%. And the reduction in input-output power was maximum when the migration was done from SSTL18 to PCI 33. And the reduction was of 91.30%. Now the leakage power dissipation. Leakage power is basically on behalf of the junction temperature when the device is not programmed using the logic. Then the power at that time is termed as leakage power. And as we can see from the bar graph, the reduction was almost same for mobile DDR HSUL and SSTL18, and it was maximum for PCI 33. So at 25 degrees Celsius, the reduction from PCI 33 to other IO standards was 4.26%, and the reduction was maximum at 35 degrees Celsius, and that was of 5.08%. And at 50 degrees, the reduction in leakage power was 2.25%. Now the total power. Total power is the maximum power that any device consumes. It is the total power which contributes the clock power, leakage power, input-output power, logic power, etc. The clock power was maximum for SSTL18 and it was minimum for PCI 33. So taking the maximum and minimum, when the migration was done from SSTL18 to PCI 33, the reduction in total power at 25 degrees Celsius was 26.32%. At 30 degrees Celsius, the power reduction was 24.69%. At 35 degrees Celsius, when the IR standard was migrated from SSTL18 to PCI 33, the reduction was 22.72%. As we can see, the reduction was maximum at 26.32% at 25 degrees Celsius. Now, with this I conclude the IO power reduction was maximum for from migration from SSTL18 to PCI 33, and that was of 91.30%. And the leakage power reduction for mobile DDR, HSUL12 and SSTL was same. So when the IO standard was migrated from PCI 33 to these input-output standards, then the leakage power reduction was maximum, that was of 5.08% at 35 degrees Celsius. Now the total power reduction. As we have seen in the previous slide, the total power reduction was maximum when the IO standard was migrated from SSTL18 to PCI IO standard, and that was maximum at 25 degrees Celsius and was of 26.32%. This design is implemented using the input-output standard, so there is no issue of transmission line reflection. So this makes our design reliable. And this design is also cost effective as it has been implemented using the FPGAs. And this design in place of the fabric design and the ASIC design approach. So that's why it is better than those designs. Thank you.
You designed it for a room sensor. What other applications can be used for? Do you have other applications?
Yes, it can be used where to detect the temperature, like in boilers or other industries where the temperature may rise, and human that can be hazardous for humans, like in case of fire activity or others.
Room is a kind of a nice environment.
Yes.
The other environment like boiler or something, they there are other systems possible for safety, at what temperature it can be performed.
Any other questions? Thank you.